Hey guys, in this experiment we are looking at evaporation and intermolecular attractive forces. So evaporation is a physical property. That means it is something that we can observe, but it is controlled by chemical processes that we do not see. And that's why we want to understand what are these chemical processes that produce the effect of evaporation that we can observe. And have you ever wondered why we use rubbing alcohol and not water for cooling? Well, at the end of this session, you should be able to understand why that happens. And so if you look at every compound or molecule, you will see that the composition of that molecule, each atom has specific electronegativity value, and each bond, because of this electronegativity difference between the atoms forming a bond, we have something called a dipole moment. And so this causes the molecule to be polar, and then the polarity of the individual bond will therefore determine the overall polarity of the whole molecule. Okay, so as we say that the overall polarity of the molecule will determine the interaction between two or more molecules forming this compound, and the type of intermolecular force between the two molecules also determine the strength of the intermolecular force of attraction. So for covalent compounds, we have three main types of intermolecular forces of attraction that is listed here. So we have, for example, hydrogen bonding, polar attraction, which is also called dipole-dipole interactions, and London dispersion forces. So for hydrogen bonding, it is a special type of dipole-dipole interaction that occurs when a hydrogen atom of one molecule is interacting or is bonded to an oxygen or a nitrogen or a fluorine of the other molecule. So for example, here we have two water molecules. Please do not confuse the covalent bond between the hydrogen and the oxygen of this one particular water molecule. But for you to have a hydrogen bonding, you need to have an oxygen in one of the water molecules and a hydrogen of the other water molecule interacting. So this arrow here points to the hydrogen bond. So apparently the hydrogen bond is the strongest of these three intermolecular forces for covalent molecules. And when we talk about dipole interactions, these are interactions that form between molecules of substances that are polar. So we have a partial positive and partial negative ends of these polar compounds being attracted to each other. And then in dispersion forces, this is caused by the fluctuation in electron distribution, and each compound has a dispersion force. It just depends on the size of this compound. So the larger the compound, the bigger the dispersion force. Alright. So this is another table that shows you the relative strengths of the intermolecular forces and specific examples that you can look at. So when you so these first three are formed in covalent compounds, and then the ion dipole and ion interactions, we will look at them more deeply when we examine another physical property, solubility, and this will be in the next week's experiment. Alright, so what is evaporation, or what happens to cause evaporation to occur? So we know that evaporation is a physical process, as I had mentioned before, and it is an endothermic process, which is to say that the molecules that are escaping into the gas phase are absorbing heat from the surrounding, and this leaves the surrounding cooler than it was. So if you think about any liquid, for example water sitting in a tube or a beaker, it is held together by these intermolecular forces of attraction, whether it's dipole-dipole or the hydrogen bonding. But then when these forces are weakened, then some of the molecules will escape to the gas phase from the liquid phase. So we have molecules that are escaping into the gas phase, and they are taking away heat from the surrounding. And so the cooling effect, that means that the temperature of the surrounding that is left behind is lower than what was, and this cooling effect will be dependent on the rate of evaporation and also the heat of vaporization. So I just want to show you this slide here explaining how weaker substances that have weaker intermolecular forces will have more molecules escaping from the surface of the liquid compared to those that have stronger intermolecular forces of attraction. Okay, so as I said, that the cooling results in the cooling depends on the rate of evaporating molecules and also the heat of vaporization. So the heat of vaporization is just like how much heat is taken from the surrounding by each molecule that is evaporating. And so as you look at this and think about what I said about the rubbing alcohol and water, so if you look at the structure of water, it has hydrogen bonds, right? The rubbing alcohol also had hydrogen bonding, but the water molecule can form more hydrogen bonds with other water molecules, and this gives it a stronger intermolecular force of attraction compared to the rubbing alcohol. So we expect, because the rubbing alcohol has weaker forces of interaction compared to the hydrogen bonding that is in the water, then we expect that the evaporation process for the rubbing alcohol will be higher, and its cooling effect will be also larger compared to that of water. Right, so in our procedure, you will watch the video that your instructors created for you to obtain the data that was collected, and we'll basically examine 7 compounds. Some of these compounds may be related to each other, to examine the relative strengths of the intermolecular forces of attraction. And these 7 compounds will be allowed to evaporate from a filter paper that is attached to a temperature probe, and the temperature probe will enable the measurement of the initial temperature and the final temperature after evaporation has occurred. And in your data analysis, you will just obtain the change in temperature, which is to say the initial temperature minus the final temperature, or in simple terms, you take the final temperature, you subtract the final temperature from the initial temperature, and that should give you the change in temperature. And just another concept to remember, the larger the change in temperature corresponds to a weaker intermolecular force of attraction, and that means that the most cooling effect will be observed when the change in temperature is larger. Okay? And so in your report sheets, once you have watched the videos and collected the data, you will be able to answer the questions. Please download this report sheet from TopHat and then fill it, answer the questions, and then submit it on the date that's assigned to you by your instructor. Just remember that no report sheets will be accepted late. Submit it on time, and also upload your notebook record, which should have your pre-lab assignments, class results and discussion from the videos you watched, and also that has a conclusion aspect to it. Alright, so next week we will continue the topic of intermolecular forces of attraction, but also looking at Another physical property, solubility, just seeing how these intermolecular forces of attraction play a role in whether a substance is soluble or not in another substance. So please have your pre-lab prepared before you collect the data, basically before you watch the videos that has your data collection. And it needs to have an appropriate heading, the date, the purpose of the experiment, the procedure written in your own words, and also data tables if those are needed. And just to be clear on some of the files that we will be uploading on TopHat will be logger profiles, and you will need to have logger pro for you to access these files. So please make sure that you have logger pro on your personal computers, and those links, the download links and instructions should be in TopHat. Alright, good luck.